In this video, I'll be talking about capacitors in DC for the subject N104. So what is a capacitor? A capacitor is defined by its capacitance and is a term used to determine how much charge can be stored. Its mathematical expression is Q equals CV, where Q equals charge, C equals capacitance, and V is in volts. The SI unit for capacitance is farads, named after Michael Faraday. The capacitance can also be defined not only by charge in volts, but by its area of the plates and the distance between them, given in the formula shown here above. It only depends on its area and its distance between the two isolating conducting plates. The capacitor is maximized when the area is large and the distance is small. When capacitors are in parallel, the total capacitance can be calculated by simply finding its sum, opposite of the resistors. To increase the total level of capacitance, the capacitors must be connected in parallel. When capacitors are in series, the total capacitance can be determined by finding the reciprocal of its sum. We should also note that the total capacitance is less than any other singular capacitor in series. The energy in the capacitor is shown here above. Work must be done by an external agent to charge a capacitor. Also note that regardless of its geometry, these equations are still valid. The purpose of a dielectric is to increase its overall capacitance. When the space between the plates were to be filled with a dielectric material, the capacitance would increase by a factor of K. Here is a work example regarding capacitance with a dielectric. Please note, when attempting this question, we must change the values to SI units. From the graphs above, we should notice how the x-axis is measured in time constant, not minutes or seconds. Likewise with the y-axis, where it is measured in a percentage of its maximum volts. Note, for any combination of resistor or capacitor, after one time constant, the voltage across the capacitor will always be 63.2% of its maximum. Likewise for when the time constants are at 2, 3, 4, and 5, where at 5 time constant, the capacitor is fully charged. At steady state, when the capacitor is completely charged, it is an open circuit. For a discharge phase, the formula is very similar. Only difference is the fact that there isn't a 1 minus for VC, as there is no minus for IC. This slide shows a worked example regarding an RC charging circuit. We should note that at 5 time constant, the capacitor is fully charged. Other than that the question is fairly straightforward, as we only need to plug in the values in the formula. This concludes my video. Thanks for watching.